Hey everyone. So in this video I wanted to do an example of how to divide complex numbers because it's a little bit trickier. So we're given two complex numbers here, z and y, which are elements of all complex numbers, and they're both defined already for us in rectangular form. So let's say that the question is asking us to do z divided by y in this case. And when we're multiplying, it's a lot simpler because we can distribute the complex numbers, the real and the imaginary part, just like two binomials. But when we're dividing, we can't really do something like that. So what we're going to do is actually take advantage of the conjugate of the denominator. And I'll show you in a second what that means. So z divided by y. Let's write out exactly what that is. So we have 2 minus 3j, where j is our square root of -1. Sometimes you'll see it as I, but in engineering it's often written as j. So we've got this. Okay. And you're going to follow the same method every time you're going to divide. And that is going to be multiplying the numerator and denominator by the conjugate of the denominator. So reminder, the conjugate, if we have a minus b, the conjugate would just be a plus b. So in this case we have a plus b, so the conjugate will be a minus b. So we'll do -1 minus square root of 5j divided by -1 minus square root of 5j. Let me just put brackets around this to make things extra clear. Okay. And the reason that this is helpful is because if you look at the denominator, this is actually just the expanded form of the difference of squares. And the reason we want a difference of squares is because we know that j squared or I squared is going to get rid of that imaginary component, because square root of -1 times the square root of -1 is just -1, which is a real value. This way, we're just dividing by not a complex number, and this we can simplify and get a nice clean answer. So in this case, here we have, let's just expand our numerator, and this is pretty straightforward. 2 times -1 is -2. 2 times the negative square root of -5j is minus 2 root 5j, and then minus 3j times -1 is positive 3j, and we have -3 times -root 5 is positive 3 root 5, so that's positive 3 root 5, and we have j times j, which is j squared. We'll write that as j squared for now. And then recall, the denominator, we're just going to be making this the simplified form of the difference of squares. So that's the first term squared, which is -1 squared, minus b squared, which is, in this case, well, we have square root of 5, so this will be just 5. And then we have j, so that would be j squared, right? Hope that makes sense. Okay, great. So now we really just need to simplify this. So let's simplify the numerator. We know that j squared is just -1, so that'll be -2 minus 3 root 5 as our real component of the numerator. And the imaginary component of the numerator, we have 3 minus 2 root 5. So that's plus 3 minus 2 root 5. And again, this is the imaginary component, so it's all multiplied by that j term. Okay, that looks good. Can't really clean that up much. And then we can clean up the denominator, though. Let's make this real. So again, j squared is -1. So if j squared is -1, that'll be plus 5. So -1 squared is +1 plus 5, which is just 6. Great. And then let's just clean this up as best as we can just for communication. So negative 2 divided by 6 is minus a third. We've got minus a half root 5. And then we've got, so this is our real term, plus we've got half minus 1/3 root 5. And this is all times j. So this would be the answer for z divided by y in rectangular form. And yeah, that's pretty much it. Just follow the same method for whenever you're dividing complex numbers, but the caveat is that it does have to be in rectangular form. So if you're in any other form, you're going to have to convert to rectangular form and then follow this method.